Hello and welcome to Lab 4. The purpose of this lab is to predict the motion of a mass attached to an oscillating spring. To do this, I will use Newton's second law and the energy principle. It was found that the predicted positions and the experimental positions were quite similar and that the system followed the energy principle. I begin with this video. For the purpose of this lab, I will be considering the spring and the mass to be my system. I use the attachment point here to be the origin of my axes. Now, let's look at the information we have. First, I was given that the mass was 0.402 kilograms. I was also given the length of the spring with the mass attached when it was at rest. This length was 0.7 meters. Also, I was given that the time between each frame in the video was 10.4 seconds. I used the graph created by Tracker to estimate the time for one period of the spring's oscillation. To do this, I divided the time it took for 5 periods of the oscillation and divided it by 5 to find the average. Next, I needed to calculate the stiffness of the spring and the relaxed length of the spring. I used these two equations, here and here, to do that. Now, let's look at the energy principle. The total change in the energy of the system is equal to the change in kinetic energy plus the change in potential energy. Because the only forces acting on the system are the spring and the earth, the potential energy can be separated into the potential gravitational energy and the spring potential energy.
Because I have chosen to take the mass and the spring to be the system, there is no transfer of energy into or out of the system. For this reason, delta E is 0. This also tells us that the net force equals the force of gravity plus the spring force. Now I have enough information to begin to predict the motion of the mass and the spring. Let's start again with the fundamental principle, this time Newton's second law. I will be using this to predict each new position of the mass. I already know that the net force is equal to the sum of the gravitational force and the spring force, so those values, as well as the fact that the mass started at rest, can give me the new velocity of the mass. From there, I can use this equation to find the new position. Here is a position versus time graph of the y positions. As you can see, they are very similar. Here is the change in kinetic energy, the change in gravitational potential energy, the change in the spring potential energy, and the change in total energy plotted on energy versus time graph. You can clearly see now that the total change in energy, as I said before, was 0. This shows that the oscillating spring mass system follows the energy principle. Since this spring mass system moves in 2 dimensions, it has an up and down motion and a side-to-side motion. The up and down motion is the same as a vertical spring, which only moves in 1 dimension. For this reason, I use the time of 5 oscillations from the y position data when calculating the period. The side-to-side motion is the same as the motion of a pendulum. Because of this, the period calculated from the x position data and the period calculated from the y position data are different.